We are now here at our experiment number 2. But what is linear motion? Linear motion is a motion that is natural to an object, moving in a straight line. According to Newton's first law of motion, an object not affected by any force will continue indefinitely in a straight line. What is acceleration and velocity? Acceleration is the rate of change of the velocity of an object with respect to time, while velocity is the rate at which the position changes. The average velocity is the displacement or position change per time ratio. The materials will be toy car, measuring tape, masking tape. Now, let's get started.
What a wonderful world.
Now let's get the average time of each strips since we have three trials. So the formula is the time 1 plus time 2 plus time 3 divided by 3 to get the average time of the trials we have. So let's start with the first strip. We have the first time, or the time we get in the first place is 0.72 plus 0.86 plus 0.72 divided by 3, and the answer is 2.3, then divided by 3 is equals to 0.76 seconds. Now for the three trials, we have the three times that we have, which is this is the first trial, for the second trial, and the third trial. So for the second one, which is we have the second strip. So we have the second strip, then 0 to the second strip, or the 12 inches, we have the first time, which is 0.90, 0.83, 0.86. Using the method we used a while ago,
we add this 3 then divided by 3, and the answer is 0.86 seconds. On this one, which is the strip 3, which is 0 to 18 inches, the first time is 0.98, 0.1, 0.11, 0.96. Using the same method again, we're gonna get 1.02 seconds. In this fourth, we have 1.12, 1.20, 1.29. The result is 1.20 seconds. For the fifth strip is we have 1.28 seconds, 1.40 seconds, 1.31 seconds. Add them all, when divided by 3, the result is 1.33 seconds. This is their average time for each strips. Now let's get the average time of the 6 to 10 strips. Now this is for our 6 strip to 10 strip. So we have the first time, which is the 1.49 for the first trial. Second trial is 1.35 and 1.36. Now let's add them all, then divided by 3. The result will be 1.4 seconds. Same goes as this 7 strip, which is 1.2, 1.55, and 1.63. The result will be 1.57 seconds. 1.64, 1.65 plus 1.58 divided by 3. This is would equal to 1.62 seconds. 1.59, 1.69 plus 1.64 divided by 3 is equal to 1.64 seconds. And lastly, 1.55 seconds plus 1.72 seconds plus 1.86 seconds, all divided by 3. The result will equal to 1.71 seconds. And these are also their average time. Now let's get the acceleration for each of the strips. But before that, let's find the velocity first. Now let's have this example, formula either. This is the formula for the velocity, which is the displacement divided by the change of time. So to find the velocity, we have the displacement, which is equals to 6 inches. But 6 inches is something we should convert into meters, so we can make it more convenient afterwards, since acceleration is equals to meter per second squared. So 1 inches is equals to 0.0254 meters. Now let's convert 6 inches into meters. 6 inches equals to 6 inches equals to 0.1524 meters. Now let's use this instead of 6 inches. Divided it by the change of time, which is 0.76 seconds. So the change of velocity is equals to 0.1524 divided by 0.76. 0.20 meter per second. So this is our velocity for the first strip, or the 6 inches. Let's find the velocity first. The displacement. So we have the 12 inches. Let's convert it into meter. The result will be 0.3048 meter divided by change of time. The change of time for the second one is 0.86 seconds. So let's divide it. 0.3048 divided by 0.86. We would come up with the velocity of 0.35 meter per second. Now let's find the acceleration for the third strip. So same procedure. Velocity is equals to displacement. So let's convert the 18 inches into meters. So 18 inches, so 18 inches is equals to 0.4572 meter divided by the third average time that we got for the average time we got for the third strip, which is 1.02 seconds. So the velocity will be 0.4572 divided by 1.02. This would be 0.45 meter per second. Now so same procedure as follows. Let's find the acceleration. So let's get first the velocity. So we have now the fourth strip. So for the fourth strip, we have the displacement or the length niya, which is 24 inches. Let's convert 24 inches into meter. So 24 inches is equals to 0.6096 meter divided by the change of time or the average time we have for the fourth strip, which is 1.20 seconds. So our velocity is equals to 0.6096 divided by 1.20 equals to 0.51 meter per second. Now let's find the acceleration for the fifth strip. So velocity is equals to the displacement. So let's convert the 30 inches into meter. So 30 inches is equals to 0.762 meter divided by the change of time or the average time that we got, which is 1.33 seconds. So the velocity is equals to 0.76 divided by 1.33. This would equal to 1.57 meter per second. Now let's get the acceleration for the sixth strip. So velocity is equals to the displacement over change of time. So displacement, we have the 36 inches. Now let's convert it into meter. We will have 0.9144 meter divided by the change of time. So the average time that we got a while ago is 1.4 seconds. So velocity is equals to 0.9144 divided by 1.4. This would equal to 0.65 meter per second. Now let's get the acceleration for the seventh strip. So velocity is equals to displacement, which is 42 inches. Now let's convert it into meter. We will have 1.0668 meter divided by the change of time or the average time we got a while ago, which is 1.57 seconds. Now the velocity is 1.0668 divided by 1.57. We will come up with the answer 0.68 meter per second. This is our velocity for the seventh strip. Now let's get the acceleration for the eighth strip. We have the velocity displacement, which is 48 inches. Now if we convert it into meter, we will have 1.2192 meters divided by the change of time or the average time that we got, which is the 1.62 seconds. So our velocity will be 1.2192 divided by 1.62. This would equals to 0.75 meter per second. Now let's find the acceleration for the ninth strip. We have the velocity is equals to the displacement, which is 54 inches or 1.3716 meters divided by the change of time or the average time that we got, which is 1.64 seconds. Velocity is equals to 1.3716 divided by 1.64, 0.84 meter per second. Now let's find the acceleration for the 10th strip, which is, let's find the velocity since we have the displacement here. So we have the 5 feet or the 60 inches. So let's convert it into meters. So we will have 1.524 meters divided by the change of time or the average time. So we have 1.71 seconds. So the velocity will be 1.524 divided by 1.71 seconds. 0.89 meter per second. Now the acceleration will be the velocity divided by the time. Now let's start making our velocity time graph.
Now this is the scanned picture that we graphed manually a while ago. Now this is our velocity time graph on the online Desmos platform. For the conclusion, we observed that the longer the length of the strip, the more time it takes for the toy car. As the time increases, the velocity also increases.